Hello everyone. Previously we had discussed on the Morse algorithm, right? So today we'll be discussing on the Boyer-Mori algorithm, right? Also known as Boyer-Mori majority vote algorithm, right? So let's get into the definition part. Let's see the definition part. Let's try to understand it, and let's move on with the explanation part as well. Then let's consider the algorithm. Let's write the algorithm. Let's try to understand the algorithm with a very simple example as well, right? So let's get into the definition part first. So the Boyer-Mori algorithm, vote algorithm, or the majority vote algorithm, this one, the Boyer-Mori majority vote algorithm, is a linear time algorithm, right? Used to find the majority element in the array. Basically, it is used to find the majority element in the array, the element that appears more than n by 2 times, right? So it is used to find the majority element in the array, the element that appears more than n by 2 times. So it works by maintaining a candidate and a counter while traversing the array in one pass. Again, it works by maintaining a candidate and a counter while traversing the array in one pass, right? So this is the definition part of it. Simple, right? So basically, it is used to find the majority element in the array, right? So when I say majority element in the array, the element that appears more than n by 2 times, right? So it works by maintaining a candidate and a counter. This part is very important, right? So just keep this in mind while we write the algorithm. This will be very handy, right? So it works by maintaining a candidate and a counter while traversing the array in one pass, right? Let's come to the explanation part here. So what is the main idea? Let's try to understand. So the idea is to keep track of the candidate element that could be the majority, right? So we have to keep track of the candidate element that could be the majority, right? So first of all, what we'll do, we'll maintain a count. First, we maintain a count. If count becomes 0, we pick the current element as the new candidate. Again, what we are doing here, if the count, we are maintaining a count, and if the count becomes 0, we are picking the current element as the new candidate. If the current element is equivalent, or if the current element equals the candidate, then we have to increment the count, right? So otherwise we have to decrement the count. This is fine. At the end, the candidate is potential majority element. Again, at the end, the candidate is potential majority element. It needs a second pass to verify on some variations. Again, it needs a second pass to verify on some variations. So let's try to understand the same thing whatever we have discussed from here. Let's try to understand the exact same thing with the help of the code, right? So let's start writing the algorithm or the code. Nothing but Boyer-Mori majority vote algorithm, right? I'll just go with the function here, majority element. This is fine. So let me pass the numbers as parameters. So within this particular function, let's initialize the candidate as none and count as 0. So I'll just go with candidate here. This is fine. Sorry, what did I keep here? Candidate, and let me go with a count. So let's initialize both with none and 0. Candidate as none and count as 0 initially. Now what was our step 2? So we have to traverse through each element on the list, right? So that's what we need to do. So for num, in nums, basically, so if the count is 0, see here, if the count becomes 0, then we pick the current element as the new candidate, right? So we have to pick the current element as new candidate. So let me write the simple if condition. What is the condition? If count is 0, right? So if the count is equivalent to 0, then what we will do, we have to pick the current number as candidate. Nothing but I'll just go with the candidate here. Let me assign the candidate to the number. This is fine. Next step is, uh, what if the current number is same as candidate? Then we have to increment the count, right? So if the current number is same as candidate, then we have to increment the count. This part we are done with the line number 11. This part, now we are going with this part. If the current element is equivalent to the candidate, then we have to increment its count, right? So let's try to articulate the same thing in the form of code here. So let me leave one line here. This is fine. If the current number is same as candidate, right? So if number equivalent to candidate, then what we will do, so then we have to increment the count. So I'll just go with the count equals count plus 1. This is fine. Next, let me go with else here. else this is fine. Now else what we have here, otherwise we have to decrement the count. Otherwise we have to decrement the count. We have considered count itself right here. So I'll just go with count equals count minus 1. This is also fine, man. So final step we have to finally we have to return the candidate, right? So nothing but the potential majority element. Here we are done with these things. First we maintain the count. If the count becomes 0, we are picking the current element as new candidate. That's what we did here. This one fine. Next, otherwise if the current element is equivalent to the candidate, then we are incrementing the count, this part. Else if the current element is this one is not equivalent to the candidate, then we will decrement the count, so this part. So now we are done with almost all the things. At the end, the candidate is the potential majority element, right? So in the sense we have to return the candidate. Here I'll just come here. Let me go with this one, return. We have considered candidate itself, right? So return candidate. So we are done with the algo. Simple, very simple, right? So let me go with the example input here, or the example usage. So I'll just go with array. Let me consider some random numbers here. Let me go with 2 comma 2 comma 1 1. Let me consider some more times triple one here. 2 again, 2 4 times we have 3 2 4 times we have 1, we have 3 times, right? So this is fine. So now let's go with the function call. I'll just make use of the result here. Let me go with the function name, majority element. Majority element, we have to pass the array. I have considered array itself, right? A double R. This is fine. Yep. Finally, we have to print the result. So let's print the result for the interactiveness. So I'll just go with majority element here. This is fine. So let me pass the result. This is fine. So the output that we need to get here is basically 2, right? So the majority candidate here is 2, because see here we have 2 4 times, right? So 1 we have only 3 times, so 2 increases basically accordingly. 1 2 3 4, the frequency is 4 here, so we need to return basically the majority element is 4 itself, right? So rather than 1, so output that we need to get here is 2. This is fine, man. Before uh, running the code, I'll just explain the same thing whatever I had explained earlier. Let me explain this one quick, whatever the code that I have written here, right? So candidate comma count, so this one whatever I have written, line number 20, so this starts with no candidate and a count of 0, right? Initially, right? We are looping through the each number. If the count is 0 here, the line number 23 I'm speaking of, if count is 0, then we are making the current number the candidate, right? So if the current number is equivalent to the candidate, then we are incrementing the count. So this sorry, this part, line number 26 and 27, right? So if the current count, if the current number is not equal to the candidate, then we will be decrementing the count, right? So that's what we are doing here. So see here, I have misspelled, thank god. This is fine. I had misspelled the this one count basically. After doing that one, or after one pass, the candidate is the majority element. That is the reason I have returned the candidate here, right? So we are printing the result here, this part, 33 to 35. This is fine. Now let me run the code. Sorry, why did I give print here? So this one will be Python. So let me come here, right click, F2, or this one, file name, just copy this one, .py. See here, the majority element that we are getting here is 2. Very simple, right? So this is the Boyer-Mori majority vote algorithm. Very simple. Again, the Boyer-Mori majority vote algorithm is a linear time algorithm used to find the majority element in an array, right? So the element that appears more than n by 2 times, we know this, right? So this works by maintaining a candidate and a counter while traversing the array in one pass. That's what we saw, and the explanation in the algorithm we have seen with the example, right? So this is fine. We are done with the Boyer-Mori algorithm, right? Majority vote algorithm. Now, let me summarize whatever we have learned so far. So this is going to be the last algorithm that we'll be discussing within the this one array-based algorithm playlist. array based algorithms playlist, right? So now just keep these four things in the mind, man. Whenever we hear Boyer Mori, this one algorithm, majority vote algorithm, just try to keep these four things in the mind. The Boyer Mori algorithm, what it finds the majority element on big of n time and big of one space. This is fine. It works by keeping a candidate and adjusting its count as we can scan the array. This is the second one. That's what we saw, right? So the final candidate is the majority element. This is fine. Next, finally, this is efficient for, this is very important. Where it is efficient, when we can use, let's see the same. It is efficient for scenarios like finding the leaders in elections, right? So this is this one, very efficient on this one. This is very efficient for the scenarios like finding the leaders in elections or dominant elements in the streams or the dominant elements in the streams. So this will be very helpful, right? So I hope this part is completely clear, right? So I hope this algorithm is completely clear. So we are done with the Boyer-Mori majority vote algorithm. So next we are done with the array-based algorithms. 8 algorithms we have. See here. So I'll be uploading the same thing on my GitHub as well. Right. So you can just check the code and the explanation there, and you can just come to the YouTube if you are comfortable watching the video. Please do watch it. And one more thing, man. 90% of the people who are watching the video has not subscribed. So please do subscribe and hit the like button as well. So it'll just give me motivation. That is one thing that I wanted to say. So most of the people are just watching and leaving, so you can just give me a thumbs up so that it motivates me to do more videos, right? If you're liking it. Right, so this is one thing I wanted to say, and one more thing. So we have done the this one, we are done with the array based algorithms. 8 very important algorithms, right? So here I'll be uploading the same thing on my GitHub as well. See, first I went with the Java. So I have not explained in the Java because so I do code in Java basically. When it comes to CP and other stuff, I do code in Java. So Java is very important as well. So for me, so I have explained this one in the Python. The same thing applies to the Java as well. You can just refer to anyone which you're comfortable with, which programming language you're comfortable with, right? I don't know. So you can just go with the Python or the Java, right? So I have explained the things in Python, so I can just consider the same similar thing in Java as well, right? So the code will, I'll be uploading on both, this one, what do we call the programming language, this one Python as well as the Java. No worries with that, right? So next we'll be discussing on the string algorithms. When I say string algorithms, the first thing that comes to my mind is this one, these three things basically. What do we call KMP, Z algorithm, as well as this one, try, right? So there are many other algorithms as well. If I remember, there are many other algorithms. So if I try to remember some of the algorithms, it may be Robin Cobb algorithm, Manish's algorithms, right? So rolling hash, that is also there. Edit distance, there are n number of algorithms. We'll be discussing every algorithm one by one. So we will be going with around 10 algorithms, 10 string algorithms, right? KMP, Robin Cobb, Z algorithm, Manish's algorithm, suffix array construction, also known as Kasai's LCP, right? So you would have heard about this one. So suffix automation. So Aho Korasik algorithm, that also will be going for the multiple pattern matching. And try, we know try. This one rolling hash, we know rolling hash, as they have taught us this one rolling hash algorithm in the colleges as well, right? So also known as polynomial hash algorithm. So we'll be going with the edit distance. Edit distance is nothing but Wagner Fisher DP, right? So this one also, they might have taught you this one within the college as well. So these 10 algorithms we'll be discussing within the string based algorithms, right? So now we are done with the array based algorithms. These 8 algorithms are very important accordingly, with my opinion. So whatever I felt very important, so I have explained, I have tried to discuss basically rather than explain what, so we tried to discuss, right? So I hope all the array based algorithms are completely clear, whatever we have discussed, right? So next let's move on with the string based algorithms from tomorrow. For now, this is it. Thanks for watching, guys.